So in this video, we are specifically going to be looking at the definition of what an exponent is and a power and how those things relate together, and some key vocabulary that you're going to be experiencing through the entire exponents lesson. All right, so key vocabulary that we're going to be looking at first off is the word power. All right, the power is the base and the exponent together. It's the number using an exponent or base. It's what is being created when you're actually doing the math. All right, the base is the common factor in a power. That's the number or variable that's being repeated. It's the big number underneath the exponent. And then finally, we have exponent, which is the number of times the base gets used as a factor and the number of times that it repeats. So at any point you want to write this stuff down, you go ahead and pause the video. All right, so we're going to be kind of looking at these three words, but we're not going to be looking at them as vocabulary. You're going to be looking at them as numbers. All right, so I kind of want to let you see how this all ties together. All right, so the 5 in this instance is what we would call the base. Okay, so remember how we just wrote up here, the base is the number or variable repeated. So in this case, my 5 is going to be on repeat. Right? The 8 in this case would refer to my exponent. And the exponent tells me the number of times that that base is going to repeat. And then finally, together, well, together, that is our power. All right, that exponent gives that base power, telling it how it's going to work together. All right, what you need to understand is that a exponent is used when I have a repeat multiplication. And repeat multiplication, and so instead of telling somebody, hey, I want you to go 2 times 2 times 2 times 2, where I have 4 different factors of 2, well, instead I would write that as I have the base of 2, that is my commonality, and I need to multiply that 4 different times. Now understand, this does not say 2 times 4. This says 2 times 2 times 2 times 2. Okay? We also need to understand how we would use our calculator to demonstrate this. Okay, so in our calculator, those of you guys that are using the same calculator we use in the classroom, all right, you're going to notice that there is our x squared. We use that one for volume a lot. And then above it is our caret, and our caret is for our exponent. So if I wanted to type in 2 to the 4th power, I would type in the 2, the base. I would type in our caret because we're raising it up. And then I would type our 4 exponent so that it all ties together. All right, so again, to type this in, we would type in 2 caret 4. So our calculator part of this is important because I don't want you worrying about doing this mentally. I don't want you to know what 4 to the 8th power is. But we need to understand that there is a tool that exists that can help us get there. Okay? The next component, while you do not need to write this down, you need to understand how we speak exponents. All right, so I have for us kind of a little table for us. Anything to the first, we would say first. So this would be 3 to the 1st power, which means it's just 3. When there's a little number 2, there's 2 different ways to say this. We can say 3 to the 2nd power, or we can say 3 squared. When I have 3 with the little 3, I am 3 to the 3rd power, or I am 3 cubed. And then 3 to the 4th power is when we start our next change. So we would use 4th. If it's a 5, we'd say 5th. If it's an 11, we say 11th. If it's a 13, we'd say 13th power. All right, so our words, similar to 1st and 4th, the only ones that have special names are the little 2 and the little 3. So I want to make sure when we're doing this, we are speaking correctly when we are talking about our exponents. All right, so let's practice some things with exponents. Mostly so I can make sure that you understand the purpose behind them and what they actually do. All right, so the first thing is simplifying. If I'm given a strand of numbers, a strand of letters, I can put them together with common factors. All right, so let's analyze this. We have 2 times 2 times 2 times 3 times 3 times 4. And to simplify means to put together what's alike. I should only have one of each thing. So in this case, I have 2s, 3s, and 4s. And so those should be in my final answer, but I should only have one of each of them. All right, so let's take a look. So similar to combining like terms, I have 1, 2, 3 2's being multiplied together. And it's important that this is multiplication because if it's addition, that's coefficients. Multiplication leads to exponents. So in this case, I would have a base of 2, because that's the number I'm dealing with, and I have 3 of them. So that would be 2 to the third. Okay. I look at this again, and now I have a common base of 3, and I have 2 of them, which means I have the base of 3 to the second power because there's 2 of them. And when I look at this, I have the number 4, and there's only one of them. So I'm going to put times 4. Now I could put to the first power because there is one of them. First power 1, first power 1. But it's assumed. There's magic math that happens because there is the number 1, but that number 1 doesn't have to be written. If the number is there, that implies the number 1. Okay? Let's take a look at this in letter form. It's the same exact strategy. All right, I analyze it and I see the letters A, B, and there's a letter C in here. So we're going to combine and notice there's multiplication amongst all of them, which means I'm using exponents. All right, again, if there was addition, it would be a coefficient. All right, so I'm going to start with the letter A. I have 1, 2, 3. I have 4 of them, which means I have the base of A to the 4th power because there's 4 A's. Let's do the next letter. I have B, so I have 1, 2 of them. So this would be B squared. Now understand when we're dealing with variables, I don't have to put the multiplication symbol. I can squish them together because squished means to multiply, as we've learned before. And then here we have C times C, which means I have C squared. Okay. So exponents are used when we have repeat multiplication. All right. Let's make sure we're able to use our calculator effectively. So in these ones, we're going to evaluate. And actually, all of these we're going to evaluate. All right, but let's start with this first one, so I'll give you a chance to write it down real quick. So I have the quantity. Notice that negative is inside with the fraction. That's important for when you do this. That 4 does not just apply to the 2. It applies to the whole fraction. Okay. If I didn't have the parentheses and the 4 was with this, it would only apply to that top. All right. There's 2 different ways that I can type this into my calculator. All right. The first way I can type this into my calculator is the whole thing. I can type in my parentheses, so I'm going to type it exactly how I see it. So parenthesis, -2, ABC 3, close my parentheses because that's a fraction, so we use the ABC button. Now I'm going to use my caret and my 4 because I'm raising it to the 4th power, and I get 16 81st. Oop, 81st. Sorry, I can write there. There's another strategy that I can do. If I'm not confident enough, or maybe I'm really good at mental math, I can treat each of these separately, where I can do -2 raised to the 4th power, and I can do 3 raised to the 4th power. These mean the same thing. So because I have the same exponent, I can keep that exponent and combine them together. And we're going to be talking about some of these rules. But I can do in my calculator -2 to the 4th power, which gets me 16. Now notice my calculator just showed negative because it's doing 2 to the 4th and then it's applying negative. If you want the true correct answer, you should have used parentheses. Okay. And then if I do 3 to the 4th power, notice I get that 81. So I'm going to get the same answer. All right. If it said squared, I can usually do that mentally because it's the same number times itself. If I had a 0, I'm number 1, those kind of things. Now, being that it was to the 4th power, I did need my calculator to use. But both of these strategies will work. I can type the whole thing in, or I can do numerator and denominator separate. Okay. Sometimes we have to evaluate by plugging in. So it's telling me that A is 3 and B is 5. So if A equals 3 and B equals 5, well, A squared plus B 4th would be what? Okay, and again, if you need a pause to actually write this down, please feel free. So what I would want to do with this is I would want to rewrite. A is 3, so I have 3 squared. And B is 5, so I would have 5 to the 4th. And then again, I'm doing the math. 3 times 3, well, this would be 9. And 5 times 5 times 5 times 5, well, I don't really want to think about it, so I'm going to do 5 caret 4, and I get 625. And then it's just asking me to add those together to make 634. And then finally, I have 8 to the 0th power. Now, a lot of times you guys like to say, oh, that's 0. Well, then why did they even have it? Some of you guys like to say, oh, that's 8. Well, then what's 8 to the 1st power? Let's try. Let's see what happens in our calculator. When I type 8 caret 0, I get the number 1. Let's try a different number. 12 caret 0. That's the number 1 too. Okay, let's try 125 caret 0. The number 1. All right. So anything to the power of 0 is 1. So a way to remember it, 0 and 1 both kind of look like O's. Isn't that crazy? So when we talk about negatives, I'm going to be proving that point, but this is just something to kind of have in the back of your brain, that anything to the power of 0 is the number 1. All right? So hopefully this basis of exponents makes some sense to you, and we're going to continue on with the logs and the rules that get applied with exponents.